How many of you guys got on Canvas yesterday and saw my assignment / notes for you to do? Good. We had notes and an assignment yesterday, 2.1. It was writing and graphing inequalities.
Wait, you said that's due tomorrow?
Yes.
Okay.
Yep. That assignment is due tomorrow. You still need to get on there and do the notes and do the assignment. So today we're going to 2.2 and 2.3. I'm combining those two sections. They're both solving one-step inequalities. Are there any questions from yesterday's notes / assignment? All right. Solving inequalities using addition. So all this mumbo jumbo on here is just to say that it's very similar to solving equations. So if you look at this inequality, -3 is less than 2. If I add 4 to both sides, or any number that's the same to both sides, I'll still get a true inequality out of it. 1 is less than 6. Okay? So very similar to when we added solved equations using addition, correct? Whatever I did to one side, I did to the other. Trying to get my variable by itself, that's what we're doing today. Okay? Any questions about that? Oops, forgot to erase. All right, so if I have the inequality, x minus 6 is greater than or equal to -10. If I had the equation, x minus 6 equals -10, what would I do to get x by itself?
You would add 6.
Add 6 to both sides, correct? So x would equal -4. Very good. Very, very, very similar today. How do you think I get x by itself for this inequality?
By adding 6.
Add 6 to both sides. So I get x is greater than or equal to -4. There's my answer. Any questions about that? Pretty easy. I do need to graph it. So whenever I solved my equation that was like this, I got x equals -4, correct? So how many solutions did I have? 1. Here, I have x is greater than or equal to -4. How many numbers are greater than or equal to -4? Infinitely many, right? Numbers just keep going on and on and on forever, greater than -4, right? So there's infinitely many solutions to our inequality here, but we can represent all those solutions with this new inequality. And we can graph it. Where's my point on my number line going to go? -4. It's going to go wherever the number that I have is. Is it going to be an open or closed dot?
Closed.
Why is it closed? It's got a line under it. It's equal to. So that means -4 is a part of my solution, correct? So I have a closed dot on -4. And which way am I shading? To the right, because I want all the numbers that are greater than -4. So that'd be to the right of -4. Yes. You might have seen this before. Don't forget your arrow with your shading, because that's letting me know that the shading's going on forever and ever and ever and ever. Any questions on this first example? Can I move on? Solving inequalities using subtraction. Same thing. Very similar to solving equations. If I subtract one thing from one side, I have to subtract the same thing from the other side. Okay? So let's look at letter A. Y plus 8 is less than or equal to 5. Raise your hand if you can tell me how to get y by itself. Subtract 8 from both sides. So Tylen, I get y is less than or equal to -3. So there's my solution. All the numbers that are less than or equal to -3. Got to graph it. If it says to graph it, you do need to graph it. Open or close dot on negative 3? Close. Negative 3 is a part of my solution here. Does anyone have any questions on how I'm determining if it's an open dot or a closed dot? So, if you notice, I have a line underneath my inequality symbol, correct? That means less than or equal to. So my solution can equal negative 3. Negative 3 is a solution. So the closed dot just means I can include negative 3 in my solution. If it was an open dot, that would mean that number is not included, but the solution goes all the way up to that number. Does that kind of make some sense? That number is just not included. So closed dot means it's included. Questions on A? Let's look at letter B. Someone raise your hand and tell me how I can solve my equation for M. Raise your hand.
You subtract 1.4 those sides.
Subtract 1.4 from both sides. So Kylie, what's negative 8 minus 1.4?
Negative 9.
Negative 9.4 is less than M. There's my solution. Questions how I got that? Not too bad. Let's graph it. Open or closed dot at negative 9.4? It's open because it's not included in this case. It's not equal to negative 9.4. Where do I put my point? Between negative 9 and negative 10. Not quite halfway. Somewhere about right in there. Now, it doesn't have to be perfect. I'm not going to get my ruler out on your assignment and check and make sure that it's exactly negative 9.4. But it needs to be somewhat close. Which way am I shading? Why to the right, Tylen? Why not to the left, which is the way the arrow's pointing? Very good. Be careful following the rule of shading, where you're just shading wherever the arrow's pointing. You can only follow that rule if your variable's on the left-hand side. So if I wanted to follow that rule, I'd flip my inequality. When I flip my inequality, my symbol has to flip as well. The open alligator mouth has to stay with the M. The arrow has to stay pointing at the negative 9.4. So that's all my numbers that are greater than negative 9.4. So that'd be to the right of negative 9.4. Questions on B? Is that making sense for addition and subtraction? Not too bad? Okay. What do you think we're going to do with multiplication and division? Same thing. There is one slight difference. We're going to look at that real quick. What'd you say? You said why? It's easy. Okay. Let's look at something real quick. So I have this inequality over here. Sorry, it's so small. It says 2 is less than 5. If you want to write that down, you can. This might be good to have written down. 2 is less than 5. So I'm going to do these operations on both sides of my inequality, and we're going to see what happens to the inequality symbol. Okay? So if I add 7 to 2, what do I get?
9.
9. If I add 7 to 5, what do I get?
If you add 7 to 5, 12.
12. What inequality symbol would go between 9 and 12?
12 is greater than 9.
Oh, we read from left to right.
9 is less than 12.
9 is less than 12, right? So did my inequality symbol change?
No.
No, it did not. It stayed the same. Let's divide both sides by 3. What's 9 divided by 3? 12 divided by 3.
4.
What's my inequality symbol?
3 is less than 4.
3 is less than 4. Very good. Stayed the same, right?
Mm-hmm.
Now let's subtract 3 from both sides. What's 3 minus 3?
0.
What's 4 minus 3?
1.
1. What's my inequality symbol? Stayed the same, right? Now let's add negative 5 to both sides. So what's 0 plus negative 5?
Negative 5.
What's 1 plus negative 5? Negative 4. What's my inequality symbol? It is less than. Remember, with negatives, it's kind of backwards from what you would originally think. Now let's subtract negative 10. So I have negative 5 minus negative 10. Stay, change.
5.
Be 5. I subtracted negative 10. So negative 5 minus negative 10. The two negatives right next to each other become a positive. So it's negative 5 plus 10. And then I have negative 4 minus negative 10. So negative 4 plus 10. 6. What's my inequality symbol? Less than, stayed the same. Now let's add 11 to both sides. What's 5 plus 11? 16. 6 plus 11. What's my inequality symbol? Stayed the same. Now let's subtract 6. What's 16 minus 6? 17 minus 6. Stayed the same. Let's multiply both sides by negative 2. What's 10 times negative 2? 11 times negative 2.
22.
What's my inequality symbol?
Negative 20 is greater than.
My inequality symbol flipped, didn't it? Hold on, let's finish the chart. Let's add 16 to both sides. Negative 20 plus 16.
Negative 4.
Negative 22 plus 16.
Negative 6.
Negative 6. What's my inequality symbol? Oh, stayed the same again now, didn't it? Now let's divide both sides by negative 2. What's negative 4 divided by negative 2?
2.
Negative 6 divided by negative 2.
3.
What's my inequality symbol?
2 is less.
Uh-oh, it flipped again. Uh-oh. Adding 8, we get 10 is less than 11. Multiplying by 2, I get 20 is less than 22. Stayed the same, stayed the same. Did everyone see that? So does anyone notice a pattern of when my inequality symbol flipped? When I multiplied by a negative number, what else? When I divided by a negative number, right? Those are the only two times it flipped. If I added or subtracted, it stayed the same. If I multiplied or divided by a positive number, it stayed the same, right? So, the only time it flipped was when I multiplied or divided by a negative number. We have to keep that in mind whenever we're solving equations using multiplication and division. Anytime we divide both sides of the inequality or divide both sides of the inequality by a negative number, we have to go ahead and flip our sign. And this is why. Okay? Does everyone see that? Okay. So I'm going to skip this slide right here. And let's look at example 3. Here's example 3. Solve x over 8 is greater than negative 5. Raise your hand if you can help me solve this inequality. How would I get x by itself, Tylen? Multiply by 8 on both sides. What's negative 5 times 8?
Negative 40.
Negative 40. Does my inequality symbol flip or stay the same?
Stay the same.
Are you sure? My right side's multiplied by a negative, right? So does it flip or stay the same?
It stays the same, right?
Why are y'all saying it stays the same?
Because the thing that.
Okay, here we go. It does stay the same. In order for it to flip, I'd have to multiply both sides by a negative number. I multiplied both sides by a positive number, so it stays the same. Does everyone see that?
Yes.
Any questions on that? Gotta graph it. Open or closed out on negative 40? Shading which way?
Right.
To the right, because I want all the numbers that are greater than negative 40. So that'd be to the right of negative 40. Questions on letter A? Not too bad? Can I erase and move on to letter B? We have negative 24 greater than or equal to 3x. Raise your hand if you can help me solve this inequality. Divide both sides by 3. What's negative 24 divided by 3? Negative 8. Did my symbol flip or stay the same? But I divided by the negative over on the left-hand side. Why?
Because you didn't divide the negative 3 on both sides.
Both sides got divided by a positive number. So it doesn't matter if one side is already negative. If I just divide both sides by a positive, it stays the same. Now, what do I want to do if I want to follow the rule of shading?
You gotta flip.
Now I got to flip my inequality to be x less than or equal to negative 8. Does everyone see that? Open or closed out at negative 8? Closed. Shading which way? To the left. I want everything less than negative 8. Questions on letter B? Not too bad? Last example. Raise your hand if you can help me on letter A. 2 is less than y over negative 3.
You multiply negative 3 to both sides.
Multiply by negative 3 on both sides. What's negative 3 times 2?
Negative 6.
Does my symbol flip or stay the same?
Flip.
Now it must flip because I multiplied both sides by a negative 3. Does everyone see that? But to graph it, I need to flip it again. So I get y is less than negative 6. Open or closed dot at negative 6? Open. Shaded which way? To the left. I want all the numbers that are less than negative 6. Any questions on A? Good? And can I erase and move to letter B? Letter B. Raise your hand if you can help me solve letter B. Someone who I haven't heard from today. Do what? Not quite. Divide both sides by negative 7. Negative 35 divided by negative 7. Does my inequality symbol flip or stay the same? Flips, because I divided both sides by a -7. So here's my solution. All the numbers that are greater than or equal to 5. Open or closed out at 5? Closed, because 5 is included in my solution. Shaded which way? To the right. If it tells you to graph, do you need a graph? Yes, you do. Questions on letter B? Can I move on? Here's our assignment. Get it written down. This is due Thursday, December 17th on Canvas.
What is this called? 2 point what?
2.2, 2.3.
With 2 assignments?
Yep. 2 sections, 2 assignments.
It'll be 2
This is one big assignment though. So you technically don't have 2 assignments. Page 71, numbers 4 through 26 evens, and page 77, numbers 4 through 20 evens. Put them on one sheet of paper. Or I mean, if you need 2 sheets of paper, that's fine. But don't make them 2 separate assignments. They're one big assignment. Okay? Once again, due Thursday, December 17th on Canvas. I have posted the semester test review onto Canvas. We are not going to have a day of review in class. So that means you need to be reviewing on your own. Tomorrow especially would be a great day to ask me any questions on the review if you don't know anything on there. Okay? Since tomorrow is your remote learning day. Everyone got it? So be looking at the review, making sure you're asking me any questions you might have if you don't understand something. Everyone got it? What hour is this? 5th hour? You got your guys' semester test is Thursday. 1st, 3rd, 5th, and 7th are on Thursday. 2nd, 4th, and 6th are on Friday. Here's how I'm doing the semester test though. I'm not counting it as a semester test grade. If you do really well on your semester test, I'm going to replace your lowest test grade with that grade. So let's say you got a 56 on a test. Let's say you get a 97 on the semester test. I'll replace that 56 with a 97.
So what if you make it back grade next semester?
I haven't decided yet, but I'm kind of leaning towards not making it replace anything. But some of us very badly need to do very well on the semester test. That way we can get a low test grade replaced with that semester test grade. Everyone got it? Semester test is over everything we've covered this semester. Exponent rules, radicals, solving equations, just everything we've covered this semester. Any questions on that?
How long is it going to be?
It's 15 questions, all multiple choice. Yep. What's wrong with that?
And we take it on a remote. We take it on a computer, right?
Can I go to
Do what?
Is it on paper or do we take it on
Paper. It'll be paper. Any other questions before I stop the recording?